is Rajim of Gas Biology.
I am Irisana Erdina Badiso.
I'm Indian.
And I'm Dinesh Rao.
So we start with our introduction for this integrated project. So first of all, the main product we have been using in this process is methanol purification. So what is methanol purification is? It's basically a byproduct. So it's a liquid operation of distillation. We can divide it into two stages. First is stopping and stage 2 is rectification. So what is the benefits of using this methanol purification is, first of all, is the reduce of stripe contains reduce plant make water requirement. That is the first benefits of using methanol purification. The second is reduce the overall water load the downstream treating facilities. The third is sufficient purity. So these are the main objective of the methanol purification. So now we continue with the flow diagram. This is the main flow diagram we have been using for this integrated project. And you know that this is the part we have been using for the task B of SUPRO. So the main objective of our is we have two parts. First thing is thermo and part B is SUPRO. So for thermodynamics, we have to calculate the values of P bubble and P dew. For the SUPRO part, we have to find how much stages is required for this process. So basically, this is our intro for this project.
So, I will present about design task A.
For design task A, we need to use an Excel spreadsheet to estimate the vapor liquid equilibrium VLE condition for the methanol purification unit D103. So, for this design task A, we need to use Excel and design a macro to get the solution. So, first thing first, we need to find P1 set and P2 set. In order to get P1 set and P2 set, we can use Antoine equation. Antoine equation in ln P1 set equal to A minus B plus C, B over B, T plus C. So we move to first sub question, which is bubble point calculation. Here the user need to input mole fraction of methanol, which is x1. So we just enter any number, let's say 0.8, and the macro help us to calculate the others, like x2, we got it from here, this equation, which is x2 equal to 1 minus x1. And P1 set, P2 set, we just take the reading before, and P, pressure of the system, we can get from this equation, which is x1 P1 set plus x2 P2 set. We can get the P, pressure of the system. And y1 we can get from this equation, which is y1 equal to s1 times with P1 set over P. And then y2 we can obtain by this formula, y2 equal to 1 minus y1. For part A2, we need to estimate the liquid composition of methanol and the pressure of the system by entering the y1, which is the vapor composition of methanol. So let's say we pick 0.6 for y1, and macro program will help us to calculate. So in order to get y2, the equation used is y2 equal to 1 minus y1, and the pressure of the system we get from this equation, which is 1 over y1 over P1 set plus y2 over P2 set. And the x1 we get from the equation x1 equal to y1 P over P1 set. And last one, x2, we get it from the equation x2 equal to 1 minus x1. So for part A3, we have three things to calculate, which is mole fraction vapor over liquid, Ki. Second, vapor composition, which is Yi. And last thing is liquid composition, which is Xi. So these are the formula that will be used in this program. So P1 set and P2 set, we just take the reading before, and for this part, the user need to enter the value for Z1 and the pressure of the system. So let's say we take 0.5 and the pressure of system we choose 44 kilopascal. So the macro will help us to calculate. In order to get P bubble point, we use this equation, which is P bubble point equal to Z1 P1 set plus Z2 P2 set. And to get dew point pressure, we use 1 over Z1 over P1 set plus Z2 over P2 set. And we proceed to X1, we proceed to K1. In order to get K1, we use formula K1 equal to P1 set over P. And then after we get K1, we calculate K2. So the formula is the same, just change the P2 set. So K2 equal to P2 set over P. After that, we calculate the V using the formula, which is here. Summation of Zi Ki over 1 plus V Ki minus 1 equal to 1. After that, we can get the V. In here, we can see that the V is 0.3637. So L, we get just from L equal to 1 minus V. And then for Y, the formula used is Yi equal to Zi Ki over 1 plus V K1 minus 1. So after we get Y1, we just use formula Y2 equal to 1 minus Y1. And then in order to get X1, we use this formula, X1 equal to Y1 over K1. And then after we get X1, we use this formula, which is X2 equal to 1 minus X1. Then we get all the data needed for this part.
To obtain the Q9, we need to calculate Q using this formula, where this is the latent heat, specific capacity, boiling point temperature, peak of the temperature, which is 60 degrees Celsius, and this is also the latent heat. We obtain the latent heat from ethanol and water from the table, and then we multiply everything here with the mole composition of ethanol and water, which is 0.9267 and 0.07. Then we'll get the Q value, and using this formula, Y equals to mx plus C to get the Q line. Then after we draw the Q line, we get the pinch point here, where the Q line intersect with the equilibrium line. We get our pinch point with 0.93 for X, 0.98 for Y.
To calculate the minimum reflux ratio. So minimum reflux ratio we can obtain from this equation, Rm over Rm plus 1 equals to Xb minus Y prime divided by Xb minus X prime. Both of this is the pinch point value. Okay. Then we calculate, we got negative 0.6. To obtain the optimal reflux ratio, we must times either in this range 1.2 to 1.5. So we choose 1.5 Rn, and this is our optimal reflux ratio, that is negative 0.9. Next, we substitute this value into rectifying line equation, that is y equals to r divided by r plus 1x plus 1 over r plus 1 xd. This 1 over r plus 1 xd is the intersection, so we got 9.5. Okay, so moving forward to the graph, this is the graph that we obtained. So we use like time method to estimate the stages. So the first step is to draw the x equals to y line. So this is our line, and then next we plot the equilibrium line that we obtained from thermal part. Okay, next we XF and XB line. So our XB value is from the mass value that we calculated, that means 0.56. So we plot it on the x equals to y line. This is our XB value, this is our XM value and XB value. So as you can see, the XD value and the XD point and the XF point is almost near. So when we draw the rectifying line, the interception on y line is far, so it's big. So the rectifying line will go up like here, like this, and then we draw once the rectifying line intersect with the Q line, we obtain stripping line. So we also draw the Q line from this equation. So this is the graph there. Okay. When we draw the intersection of rectifying line and the stripping line, we found out that it is outside the interval line. So we couldn't draw the stages. So there is no stages. So therefore there is no stages because the reason is the intersection lies above the interval line. So thank you.
This integrated project is mainly about retinal verification. So we are divided into two things, like thermal and subgroup, to find our values. So first of all, like I counted from thermal means temperature is already given in the question, and from the pressure we need to find stuff. So by using our entire equation, we can find the P1 saturation and P2 saturation. So the A value, B value, C value, we can find from the table itself. So from there, we can substitute in all the equation given, and then the equation we can substitute in the macro to find the value for P2 and P1. So that's the main thing we can calculate from thermal. So for superthermal, the step one is from F equals to Fg. This F is already given, it's 0.94, and this F we can assume. So from this we can find the mass levels together with XP. So from there, the next step is to find, we can use the formula to find the Q. So from the Q, we can obtain the Q line in the graph. So from there, we can find the pinch point, the Q line is intercepting with the equivalent line in the graph. So we can find the pinch point from the graph itself. Then from there, the next step is, from pinch point, we can find the R minimum, R minimum. So from the range, R minimum from 1.2 until 1.5, we can find the R value. So for the next step, we can find the next step is we can find the rectifying line. So basically for subgroup, the main objective was to find how many stages were required. But for what we can conclude is there's no any stages